Good morning from a wet, windy Warwick, and welcome to this focus group recording for a whistle-stop tour around pattern matching. My name is Chris Roe, and I'm a developer here at Apteco, and we're taking you through this over the next 30 to 35 minutes. Over the course of this focus group, I'm going to introduce the subject of pattern matching for those of you who have never seen it before, and illustrate this with an abstract example. And then I'm going to show some simple sequences using both the manual and longer sequences. And then I'm going to extend that by looking at wildcards and various ways of restricting the transactions used. And then in the latter part of the session, I'll cover two more recent developments through 2025, where we look at pattern matching within groups and then within campaign management work. So for those of you who have never seen pattern matching in Apteco software before, the obvious question, well, what on earth is it anyway? And this is the simplest definition I can think of for pattern matching. If you imagine you have an individual, whether it's a retail customer, whether it's a charity donor, or in our case later on, an entertainment venue, that is our individual or top level table. Underneath that, they will have lots of transactions. Maybe they're bookings, maybe they're charity donations, maybe they're retail purchases. But what we are going to do is analyze sequences of those transactions. And in order to do that, they must have some sort of order. And in almost all cases, those transactions are going to be ordered by time. So maybe it's a donation date, maybe it's a purchase date or a booking date of such kind. The patterns that we're going to look at are then achieved on variables on that transaction table, and they can either be selector variables, such as purchase type, holiday destination, etc., or on numeric variables, such as maybe basket cost or revenue or donation amount. And the whole aim of pattern matching is to scan through all of those transactions for each individual person or donor, and then look for particular patterns or behavior within those transactional sequences. And I'm going to illustrate all of the examples in this presentation with a very simple abstract concept at the bottom here. I've got a person who has transactions over 3 years. We could imagine these being 2023 up to 2025 on a single product variable, where here they are donated by letters A to D. And we're going to be looking through those transactions, which are here ordered across from left to right, looking for particular sequences. So an example pattern, let's assume we give it a name of P1, might be looking for the sequence of transactions A followed by B. And once we find that pattern within someone's transactions, we can then return lots of different things about that sequence in order to answer different types of analytical questions. So for example, we could return the name of the pattern, basically a simple question saying, did you actually do this or not? So has a person been, in this case, and bought product A and then product B in a row? And we can see, of course, that yes, they have. And these two transactions here next to each other would show that they indeed did match that pattern. Let's suppose, again, we're going to look at for this pattern A, B, but rather than looking for something that maybe happened at the very start of their transactional sequence, we look for something that happened at the very end or the last time they did it. So here we might say, well, not only do we look for the last instance of this pattern AB, we want to work out and return the end date of that pattern to find out when it was completed, to answer questions such as, have they completed this pattern? Have they bought A and then B in a row in the last couple of months? And yes, well, here they have, because we're roughly 11 months into 2025, and that B there is somewhere in that time period. Alternatively, we may say, actually, we're interested in the time taken to complete this sequence. Maybe we've asked people to buy or looking to convince them to do a certain sequence of things, and then we want to see how long it took them to do that. So here it is the difference between the start date and the end date. So for example, have they been to A, or have they bought A and then B within a 1 month period? And then we're basically looking for the time gap between those two purchases. One final thing that we can do here is to look for the number of times they've done this pattern. So maybe this is a repeated series of behaviors we're looking for. So has a person here completed this pattern maybe at least 3 times, and we can see here that they have indeed done A and then B 3 times in a row in their transactional history. Now, there's a range of different things we've just shown there in terms of things people can return about their sequence. But for other types of sequence, we'll see later, things like the length of the pattern will be an interesting thing to look at. Not in this case, we know it's a fixed series of 2 transactions. That's not always the case, so length it can be important to return. In this case, we know what all the values in the sequence are because we find it manually. Sometimes, as we'll see later, and then knowing the start of the sequence or numeric can be useful. And when we come to looking at patterns in groups, we'll also find that sometimes knowing which group it is also important. And for numeric sequences, sometimes knowing the overall revenue of that sequence or the overall average revenue of that sequence is also a useful thing to return. So when you're looking at your data and thinking about the types of analytical questions you're trying to fit into scenarios, probably these are good for using this technique. So are you looking for a sequence of transactions where there are a particular sequence of things being bought, like the A/B example we saw here? Maybe it's holiday destinations in a row, particular types of products, maybe particular channels people are interacting on. Maybe you're looking for records, or maybe the longest sequences, certain things happening to find out which people are staying with the same product, or going to the same holiday destination, or donating the same amount each month. Maybe you're looking alternatively at people who are flipping between products, going to different holiday destinations, buying different things, in order to say, well, actually, now I've got a new one, maybe they're good candidates for this offer. For numeric variables, we might look for those where the sequences are increasing in value, so i.e. their sequence of increasing purchases. And finally, we're going to show you at the end of the talk here, sequences up to or around a given date. This might be, say, a communication date. So you might look at behavior leading up to that event, or maybe behavior directly after that event. And all of these pattern matches that we define, no matter whether we do it through the expression tool or through the wizard, which I'll show you in the demos shortly, they end up coming into fast stats expressions. And those fast stats expressions can then be used in all the places you would expect. So we can select upon them, like we saw there, have you had this pattern 3 or more times? We can show them on data grids, useful sometimes for verification of whether those patterns have been matched, and also for output within campaigns. And finally, we can crystallize those into virtual variables so that they can be used further in our analysis and maybe in Orbit dashboards or audiences. Now, the holidays data set that many of you might be familiar with is not a very good one for illustrating pattern match because everyone has 8 or less transactions. So actually, in this case here, we are going to introduce a new fictional data set for a company called Apteco. This company is an entertainment company with 123 venues located throughout England and Wales. And they've been in existence for quite a lengthy period of time. So they've built up a good transactional history. And we have the information on each of the events they've held in a given year. So sometimes they're holding 30, 40, 50 events in a year. So maybe there are nearly 1,000 transactions here for each of those venues. So a decent amount of transaction information for each of my venues. And alongside that, we have a handful of different attributes for those events, such as we know when it took place, the event date. We know what type it was. They hold 3 different types of events, charity events, private events, and what they call club events. We know the band name that we're performing, and I'm not using that directly in this presentation. And we also have the revenue from each event as well. So let us have a look at some of the simple sequences that we can put together with the pattern matching tool. And the first is when we're looking for these manual sequences, like the A/B that we saw earlier. So now we're going to move from that abstract example into some concrete examples. So on that event type variable, if we searched for, say, a sequence of 3 things in a row like this, you could look for, has that venue had 3 private events in a row? You could look on the revenue variable for numeric sequences. and these are specified directly as ranges. So for example, have they had an event where the revenue was under 1,000, then between 1 and 2,000, and then over 2,000. Sometimes we don't want those values to be absolute fixed numeric values. So in this case here, the R prefix is used to say this is relative to the previous element. So here, has this venue had an event with a revenue of over 1,000, then an event which is 0 to £1,000 bigger than that, and then another one that is 0 to £1,000 bigger than that second one. We can also use here the AP prefix to look at a percentage difference as well. Sometimes you don't want to have the relative values to the preceding element, but to a fixed element in the pattern. And this curly bracket notation here with the 1 will mean that both of those elements are compared to the first element in the pattern. So as this venue had an event which had a revenue of more than 1,000, and then the next one with 0 to £1,000 bigger than the first, and then one that's 0 to £1,000 bigger than the first. And also we can create these sequences on both those selector and numeric variables together. So for example, have they had here bringing together the selector variables for those 3 private events and the revenue variables there from that middle example. The second type of simple sequence we can put together are ones that we've predefined as these kind of longest record sequences. So scan through the whole transactions for a particular individual and find maybe what is the longest sequence of the same product they bought or the same donation amount. Or maybe you're looking for ones that are just different to the last or such that they're all different. For numeric variables, it makes sense to look for longest increasing or decreasing sequences of revenue. So again, we can look at people who exhibit that type of behavior. Maybe they're becoming more important or at danger of churning. And if we're only interested in one value within our selector variable, then we can use the longest particular. So for example, what is the longest sequence of just charity events on that selector variable? And for a numeric one, we do that with a range. So for example, a longest sequence of events where the revenue of all of them was more than £1,000. Now, I'm going to show you 3 demos throughout this presentation, and for each of them, I'm going to show you the questions we're going to answer before we look at the demo. So the first one has 2 questions. So we're going to firstly look for the longest sequences option here and find how many venues have had 5 or more events in a row with a revenue over £1,000 using that longest particular option. And then I'm going to use the selector one to find a sequence of 6 different events on that event type variable using the kind of the manual the manual sequences. So in FastStats, we can create this pattern matching using the sequence analysis wizard. This allows us to step through the options very, very simply and quickly. And the first thing we need to do is choose the transactional records. So we can either drop a selection in here, or in this case, I've dropped the whole events table. So we're looking at every single event. We're aggregating this up to the venues. That's the only table I've got here. We don't need to do the optional step. I'll come to that later. And then to order the transactions, we're going to choose that event date and go from earliest to latest. And then we're going to say we are looking only here at a numeric sequence. The numeric sequence is going to work on that revenue variable. And I'm going to choose from this long drop down here, the longest particular at the bottom. When I do that, it asks me to input a range. And in here, I just need to put greater than 1,000. I then get to choose what property of the sequence to return if you match it. And here we are interested in the length of the pattern. I will then get the option to give this a name. I'm going to call this length. It will then give me a confirmation screen. And when I click on the finish button, it will then create me a FastStats expression. For those of you who've used the aggregations within the expression, we can see at the bottom we have a tab for this. It's a pattern match, and all of the elements that we've just entered in are now put into that object. I will then right drag it onto the background, just a quick way of creating a new selection with that expression directly in it. And into the box here, I just need to type my criteria, which is greater than or equal to 5, the range that I'm looking for. And then we're going to put onto that our venue name, and also I'm going to return on the second column here, when did this sequence of transactions actually start? And this will return me back a date. And then when we build this, we'll find of our 123 venues, 61 of them have had such a sequence. If I pick one at random, here I've chosen the Wimbledon venue. And if I go to my selection here, let's have a look and verify that is indeed the case. I can search for Wimbledon, go to my predefined data grid here, scroll down to the right date, about 17th, that's the start date, and you can see there are a sequence of 5 transactions where the revenue is over 1,000 for all of them. So that's shown us a particular longest particular sequence, looking for records there. And now let's do a second example, again using the wizard for that particular sequence, the manual sequence that I want of those 6 particular event types. So again, I'm just looking at all events here, grouped up to the venues table, and again, ordered by date. And this time I will use the selector variable option, drag into here the event type. And rather than using one of the longest options here, I will choose, let's define those seek patterns manually. And then opening up this little dialog, I can then create as many patterns as I like. In our case here, in our example, we're just doing 1, and they will be matched hierarchically if you've got more than 1. There are lots of symbols at the top. I'll come on to what they mean in a minute. But at the bottom, you've got all of the various values of the selector. So in this case, I've got charity concert. But I can just type into the box if I wish, if I know what they are, and that will obviously work a lot faster. So I've gone 2 charity events, 2 private events, 2 club concerts. I've clicked on OK. And then coming through to here, I only want to know now, when was the last time this happened? So we can look and see whether this particular pattern has happened within a recent time frame. So I need to return the last time it happened and the end date of that pattern in order to be able to put this onto my selection in a minute. Again, from the confirmation page, we now create the expression. If we look again, we can see that we've now got a selector pattern and all the various bits that I've added up into that wizard. When I drag that to create a selection, it gives me a date box, because if this is a date expression and it doesn't know what the end result date range is going to be, so therefore we have to help it a little bit here to say this could go back as far as 2000. And then from this predefined list of date rules, I'm just going to choose the last year to find out which venues have this particular sequence of 6 ending in the last year. And let's drag that in. And what we'll do again is we'll bring the data across just so we can verify these. And we find that there are only 5 venues that have done this. And again, the most recently finishing one of those is our Lincoln venue on the 3rd of May 2025. So let's go back again and validate that is actually the case. So if I come in here and choose Lincoln, go through to my data grid and build. And if I look at the bottom, we can see that the end date, the last date that happened to be the last transaction. You can see it's a club concert. Here are 6 transactions. That's that particular sequence that I was looking for. Now, we've seen there some very quick and simple sequences created through the sequence analysis wizard. The next section, we're going to look at how we can customize those sequences to tailor that behavior that we're looking for a little more closely. Now, I showed that there were a lot of symbols at the top of that drop down where I went into creating that manual pattern. So within those manual patterns, you have a number of different wildcards to allow you to specify the behavior slightly more accurately here. So for example, if you put a question mark at any space in a pattern, any transaction could be matched. So for example, you might look for something, make a transaction, you had a product A, they don't really mind what comes next, and then you did product B or something. Okay, so the question mark could match anything. It could be A, it could be B, it could be anything else. In patterns where you don't know what the previous one was, you can use equals or less than, or sorry, or not equal to make sure this particular value was the same or different to the last one. Inequalities can be used for numerics, so greater, less than, etc., to ensure that this item is bigger than the previous one or less than it. And just as we have in the text selections, we have a star wildcard that allows you to match 0 or more transactions. So for example, if you were looking for product A and then sometime later product A again, A star A would allow you to match that particular type of sequence. And then there is a slight specialization of that question mark behavior where we actually have a number alongside it. And the first time we see a transaction, it can be anything you like, but then that value is recorded against question mark 1. So product A, let's say, is marked against question mark 1, and then we see a product B that would mark against question mark 2. And then when we see question mark 1 again, we would use it to match definitively A. So this could be used, as shown in the example there, to look at switching between one product and then back to something else and then back to the first one. And hopefully in this example, you can see why then recording what the start value was or the second value of something could be useful, so you know what elements actually came into that particular pattern. And the final wildcards are the open or closed square bracket. And these can be used to mark the very start or the very end of the transactions that are going into the pattern match. So now, if you wanted to make sure that someone's last 3 transactions following this behavior, you could do something like A, B, C, close brackets, and you know it was the last 3 transactions that they had. The second thing that we can do is we can change the transactions that are used actually in the pattern match algorithm itself. The first method is through a transactional selection. And in this case, what we do is we firstly use that selection to choose which transactions are included in the pattern match algorithm in the first place. So for example, I could drag on a selection that said only use transactions in Q1, and then all of the rest disappear, and only those 4 transactions will go through and be used in the pattern matching. The second method is to use include and exclude lists on the variable that is used in the pattern match. So in this example, it would be a list of selected codes for the product example we see here, or a given range if it was a numeric variable. So for example, if we looked for the longest sequence of anything we liked but had an exclude list of D, every time we hit an element in that exclude list, we break the pattern and then we start counting again. So what is the longest sequence of anything that doesn't include D? Well, in this case, it's those 5 transactions because the D breaks it, and then after that, there are only 3 more transactions. Another thing that we can do is look at the time taken between transactions in order to make sure that maybe there's a maximum days between it, so there isn't a big gap between the transactions. So maybe a sequence of A, B, or DC or whatever happening a long time apart isn't really a valid sequence because they're not really connected. So in our example here, we have 2 transactions marked D and C, but there's maybe a 6-month gap between them. So maybe that's not a valid sequence DC because they're not close enough together. Conversely, you can have a minimum days between transactions, maybe because they are significant products and you want to make sure that those purchases are happening with a minimum gap between them. So in this example here, there is more than a month gap between this A-B sequence at the start here, so maybe that is enough to match. If you know that transactions are happening on a regular basis or a reasonably regular basis, then the min and max can be set to either exactly the same or nearly the same to allow for a little bit of variation, maybe on, say, a regular monthly payment. Most of what we've seen so far was available within the software for quite some period of time. The last 2 sections we're going to look at functionality introduced mainly in Q2 and then Q3 and Q4 2025. So in this first section, we are going to look at how we've extended pattern match to work within groups. And there are 2 different ways in which we've done this. Firstly, what I call patterns within a group, where we group by a selector variable. So in this case, what we do is we look at our transactions, split them out by some selector variable. Maybe it's a donation channel, maybe it's an event type, maybe it's a product or some product department or something. And then we apply that pattern matching to the transactions individually within each of those groups. All of the functionality we've seen so far in terms of the things that you can return, the wildcards you can use, they are all supported within this extension. And here is an example. If we imagined our letters here are our product codes and our channel with our color, then we could ask the question, have they bought the same product twice within the same channel? And the answer is yes, they have, because in the green channel, there are two A transactions next to each other. The second way of looking at grouping is to group transactions over a time period. And this can be especially useful if you have a large number of transactions. So for example, if you were a charity with regular donations every month, and they were quite often the same, you may want to not look at pattern matching on an individual transactional basis, may not give you that much insight, but maybe looking at them where we group over a period of, say, a year. What are the changes in your yearly donation amount? If you're a retailer who has, maybe you're going every week to the supermarket, then knowing your monthly basket amount will be a useful trend to look at. If you're a coffee shop, maybe looking at a weekly times you visited would be an interesting thing. And for online things, maybe even a day would be a way to group things up. In this particular example, with our 3 years, I'm going to group by year. So firstly, what we do is we say, let's look at all the transactions in each of the year individually. And then we look and apply some sort of numeric function to it. Maybe we just count the number of transactions, maybe look at the revenue in each of those periods. And that will then distill down to a single number. So in this particular example here, I've taken the number of transactions in each of those years and found I've got 3, 3, and then 3. What we then do is apply that pattern matching to that resulting list of values. So here, we will very quickly be able to answer the question, has this person had 3 years of 3 or more transactions? And obviously the answer is yes. So this is especially useful if you have a large number of transactions and you're not able to look at the individual picture, or it doesn't give you that much, and you want to group things up because that will give you a much broader insight. Let's have a look at how that works in practice. So in our example here, we've got quite a lot of years worth of event level data. And the question I want to ask is how many of those venues have had 4 or more years of increasing revenues? So this time, rather than using the wizard, I can create a pattern match directly from the expression. And by clicking on the icon on the right there, I create that aggregation at the bottom of my tool. I call it pattern match. And now I'm going to use that grouping drop down. And here I'm going to use my virtual variable for event year. And then I'm going to apply a function to those groups before I apply the pattern match. Here I'm going to take the sum of the revenue variable. And this will then take the revenue variable for each of those transactions, sum them up in each of those years. And then on those years, we'll apply a pattern match numeric function here and say, what is the longest such increasing sequence? And I'm going to return back how long it was. Okay, so this is the number of years, longest number of increasing years of revenue. I'll add that to my selection here, and maybe we'll look for greater than or equal to 4. I'll pull across a data grid and a venue, the length. And in this case, I'm also going to bring back the end value, which here will be the year in which that sequence ended. And our data here goes through halfway through 2025, but we have one venue that has 7 years of increasing revenue, and one here, Leicester, which had 5 years increasing revenue ending in 2024. 2025 is only half complete in this data, so maybe they would have continued doing that. So actually that venue is increasing their event revenue year on year 5 times, and that's up to date now. The final section of the presentation is going to look at how we can include dates directly within our pattern specification. This allows us to look for particular things that have happened in a sequence either before or after a given date. In Q3 2025, we incorporated fixed date values into the pattern. And this will allow us to look at, say, a communication date. In this case, maybe it's the 1st of January 2025, and look at things that happened either side of that particular date. So using those question mark and the number wildcards that we saw earlier, here I'm looking for 2 different products immediately preceding the 1st of January 2025, and then 2 different products again after that date. So maybe our communication on the 1st of January was saying, hey, we know you like lots of different holiday destinations. Here are a couple of other ones that you might be interested in booking, and then we can see whether they did it or not. So let's suppose that was the 1st of January 2025. Then B would match the number 1, question mark, B would match the number 2, C would match the number 3, and A would match the number 4. Coming up in Q4 2025, we've extended this slightly further so that rather than having a fixed date in a pattern, we can use relative dates. So this will then depend upon the date you run it, which means that they can be used automatically within scheduled tasks or in recurring campaigns. So maybe you have a quarterly campaign that say, I want to run this every 3 months, and I want to look here at somebody who bought something, don't mind what. Then we have a date, relative date, and then 2 different products after that date. And in 3 months' time, we run it again, and obviously it's picking up a very different selection of people. So we're roughly here towards the end of 2025, 3 months ago, maybe about here. So in this case, this person would match this for their question mark 1, A for 2, and B for 3. So this development is coming up in Q4 2025. So let's have a look at that in action with a demo. So here I'm going to look for a manual sequence on that event type of 2 private events, immediately before a given fixed date, and then immediately afterwards they've had these 2 club events. So here I've started with an expression ready to go. I'm going to add that aggregation, change it across to pattern match. And in this case, again, as usual, I'm doing the date. I'm going to do the selector pattern match here on that event type variable. We're looking at a manual sequence. Again, I'm going to give it a name, P1. From the drop down here, I can choose my value. Here's private event, or of course I could type it in. In the list here, you can see you've got order value. When I click on that, we get this dialog, and I'm going to enter a fixed date. The relative one is underneath it, 1st of September 2024. And then I'm going to type in club concert after that, and click OK. We're going to return back the name, i.e. has this venue had this particular sequence of events around that date. And then all I'm going to do is put onto here a data grid with the venue name and where this venue has done it. Let's have a look. There are 2 of our venues, Newport and Tranmere, out of our 123 who had this particular sequence. And let's just verify that by having a look at one of them. Here's Newport. Here are all of our fields that we're interested in. If I sort those transactions in order, and then I'm looking to go down near the end of the transactional sequence here. Okay, and if I come back up my list slightly back to the 1st of September 2024, I can see that there are 2 private events before the 1st of September and 2 club concert events immediately afterwards. Now, in this particular example, I just used one date in the middle of my sequence. I could have used the date at the start, I could have used the date at the end, or indeed, I could use the date at the start, the middle, and the end if I really needed to. So those date values within the pattern can be used to hopefully tailor a lot of very specific behavior to the scenarios that you're interested in using them for. So let's wrap up firstly by looking at what might come in the future. Well, the reason for that is that 6 years ago, I stood up on stage at Apteco Live 2019 and introduced this pattern matching technique. And at various points over the years, we've added new things to this algorithm as new use cases have come up. But actually, there are still potentially more things we can do to increase this. At the moment, the minimum maximum days between transactions are done in days. So if you knew you had a payment always on the 20th of the month, we can't make that exact because the number of days in each month changes, but we could extend that to say, well, actually, I want exactly 1 month between those transactions. I showed you that we had an R notation for relative to the previous or relative to the particular item within a sequence. I mentioned the P for percentage difference as well, but we could introduce other prefixes such as what is the ongoing sum of this numeric sequence or the ongoing mean of this particular sequence. An extension of the order values, rather than looking at relative or fixed values, is to use a kind of a time marker. So here, maybe I had product A, and then I just take an account of when that happened, and then B happened within a month, and then C happened within 2 months, and then D happened within 3 months, for example. And then we're not actually fixing the time of transaction A, but we're just fixing the interval time period before the next transactions in that sequence. I'm aware that we've covered a lot of material. It is a whistle-stop tour of pattern matching after all, but we haven't dived very deeply into any of those particular areas. If you want to know more, then on the Apteco Help Hub, there is a section on pattern match, which will tell you a lot more about all the functionality that we've covered in this focus group, as well as which releases they are available in. The QR code on the right-hand side of the screen now can be scanned to take you directly to that section of the Apteco Help Hub. So to conclude, hopefully by now you can see that pattern match is a very powerful analytical technique. Lots and lots of flexibility in terms of how you define your scenarios, your patterns, your sequences, lots of different things that you can do with wildcards to tailor those sequences, lots of different things that you can return from any match patterns. And then lots of power within the grouping and the order values scenarios that we've just shown in the last two sections. These have been developed over a large number of releases, so please do look carefully at which versions you have and which versions the functionality is in, so that you know what you can use at your current version of the software. And these have been used regularly. For many of you, you might know that I do contribute to the Guardian's Football Knowledge column. I co-author a Facebook group for English football stats, and I use this pattern match technique a lot of times. It is battle hardened. Rarely a week goes past without me answering some questions using pattern match on the longest records in English football. Partly that, and partly through requests from partners and clients, we've found other scenarios, such as the grouping transactions over a time period, and indeed the order values, where pattern match could be extended to suit particular scenarios. But there may well be scenarios that we haven't covered here, or you are thinking about, well, could I apply pattern match in that particular example? So if that applies to you, then I'd love to hear from you about the challenges that you could try and do with pattern matching, or the questions you want to answer. My email is on the screen there now, and I'd love to hear from you. That concludes this focus group presentation on a whistle-stop tour through pattern matching. Thank you very much indeed for your time.